Oh. Anyway, all right. Find inflection points. Suppose f is a function that is differentiable on an open interval from a to b containing c if the concavity of f changes at point c comma f of c, then f of c comma f of c is a point of inflection or inflection point. Okay? Yes? We went over this yesterday.
Yeah, we did.
Okay, good. All right. So basic things. Okay, let f denote function is differentiable on an open interval containing c. If c comma f of c is inflection point of f, then either f double prime of c, that's the second derivative, right, of c is equal to 0 or does not exist. Didn't we have that problem yesterday? It did not exist, right? The derivative did not exist at a certain point. So it wasn't differentiable over the entire interval. So that's what made it change there. All right. Step 1, find all numbers in which f del prime is equal to 0 or which f del prime does not exist. Use test concavity to determine the concavity of both sides at each of these. So that's the test. So the test, we plug in both sides. Okay, 3. If the concavity changes, there's an inflection point there. Otherwise, there is no inflection point. Okay, find the inflection points of this. So let's jump straight to the second derivative. Okay, so first derivative. So f prime of x is 5/3 x to the 2/3. Okay. And next one, so f double prime of x is going to be
7/9. No, I'm sorry, 10/9.
10/9 x to the
Negative.
okay. Now, see that negative exponent? Yes, the negative exponent says that goes to where?
Bottom.
Bottom! Okay, so now I'm going to rewrite this. So f double prime of x is equal to 10 over 9x to the 1/3. Like that, right? Yes.
Yeah.
Okay, that makes I have a x in the denominator, right? What can I not have in the denominator?
0.
0, because therefore that would be undefined. So, is there a point in which that I cannot have it at all?
Yes.
Yeah, 0, right?
Yes.
So, this is the part that we were talking about when I was reading through all that blah, blah, blah. Okay, so, I know everyone's paying attention, not playing on the phone, right? Okay, yes, that guy. Yes, you. All right, so, where it's not going to be defined, right? So, x is not going to be defined as 0. Okay, so x, there we go. All right, so because of that, I could actually test that one. So I'm going to test to see if that's going to be an inflection point. So, second derivative test. So that means I'm going to plug in a number to the left of this and to the right of this. Yes? Okay, so let's plug in a number to the left. So let's do f double prime of -1. Can I do the cube root of -1?
Yes.
Yes, I can. I can do the cube root of -1. So what would that give me? Just -1, right?
Yeah.
-1 times 9.
9.
Okay, so that's going to leave me with a negative 10 over 9. All right. What does that mean? What's my concavity? It's negative down. Okay. So let's plug into the right hand side. F double prime of 1 is going to be positive 10 over 9. That's going to be up. So, is there a change in concavity? Yes, so that means that 0 is a Point of inflection. So my inflection point is going to be at 0, 0. Está muy fácil. Sí. Graphs f and graphs of f prime and f double prime are shown. Assume f is continuous for all real numbers. Okay, so that means that this one right here is going to be the derivative, right? And this is going to be double prime. So that's going to be the second derivative. Man. Okay. So, let's see. So, let's do the concavity test right here. So we know, using the second derivative, it's equal to 0 where? Look at B. Look at B. See the red one. Look at the red one. Everyone, right now, look at the red one. Look at this one. Hey, hey, hey. Look at me. Look at me. Up here. Watch, I might do a trick or something. You ready? Ready? I'm going to show you guys a magic trick. Okay. You guys ready? Watch. Bam.
Viewers can see that.
I know they can. So, anyway. Alright, so the second derivative equals to 0 where? At 0 and at 1. So I have two places where my derivative is equal to 0, right? Good.
Yes.
So that means that I have x equals 0 and x equals 1. Alright, so now let's look at this. Test concavity. So on the other side of 0, so all these numbers right here are negative. Right? Those are negative. Okay, so I have a negative concavity there. And look on the right-hand side of that. That's going to be negative. Does that change? No. If it doesn't change, what does that mean?
It's like one of those.
It's not a point of inflection, is it?
No.
It's not a point of inflection. Okay? So now we're going up to 1. So on the left side of 1, it is, say negative.
Negative.
Negative. So it is negative. Now look on the right side of 1.
It's positive.
Positive. Okay, so negative, positive, is that changing? So that means that that is going to be my point of inflection there. Okay. Now, let's go over here. Remember, this thing is my slope. This is the slope. So where's my slope equal to 0? Here and here. So what does that mean? If the slope is equal to 0, I should have some mins and maxes, right? So if we're talking about this, so on the left-hand side, all this right here, that's all positive, isn't it?
Yeah.
So that's a positive slope, but on the right-hand side, this is a negative slope. So if the slope goes from negative to positive, that means that this point right here is going to be a...
It's going from positive to negative.
That's what I said, positive, negative, right?
No.
I didn't? Oh, crap, sorry. Positive to negative, so it means it's going to do what? This point right here, so I'm going to have a max at 0, 0. Okay. Now, let's look over here. Now, on the other side of this, all this right here is going to be negative, right? So, and on the other side of this, it's going to be, if it's changing from negative to positive, that's going to be a
Minimum.
I'm going to have a min at whatever, that point right there. So
4/3
that's
0? Is that what it's trying to say?
4/3 0. Actually, no. Ah,
It's
crap.
actually at x.
Yeah, it's the x coordinate, not the y coordinate. I don't know what the y coordinate is going to be yet. If I had the original function, I would. So I'm going to have a max there and a min there. So if I knew what the original function is, I could actually plug it in to actually get the y value. But since I don't, I just know that I'm going to have a max there and a min there. And so whatever my y value is would go there, y value would go there. Okay. So critical points, points of inflection, that's where it's actually changing concavity, is only going to be at x equals 1. Bam, bam. Okay, there's my, that's a picture of my hand right there. Oh, crap! There we go, okay. All right, so concave up, concave down, mins, maxes. Okay, let f, second derivative test, function f prime, f del prime exists, open interval, suppose c lies in that open interval, and critical numbers if, okay, del prime c is less than 0, local max, del prime c is greater than 0, it is a minimum. All right, so now right here. So A, determine where it is concave up and concave down. So first, do the first derivative. So f prime of x is going to be 1 minus, are you sure it's minus? Plus 2 cosine, sine, dang it. Because the derivative cosine is negative sine, right? Sine of x, and it's on the interval from 0 to 2 pi. From 0 to 2 pi. Take the next derivative, so it's going to be del prime of x is going to be, so it's going to be positive or negative? Positive 2 cosine x. All right, so think trigonometry. Everyone turn on your trigonometry brain right now. So it's not checking your Snapchat, right? Yes, I'm looking at you. Okay. All right, so where is cosine going to be equal to 0 over that interval? Pi halves. So it's going to be this right here equals 0, so it's going to be at x equals pi over 2 and 3 pi over 2. So those are going to be my points, right? So now we're going to test for that. Okay, to figure out what it's going to be concave up, concave down. Okay, so I have those. Let's see, I'm going to go 0, go to pi. Okay, and I'm going to have pi over 2, and I'm going to have 3 pi over 2 right there. All right, so we're going to test those, right? We're going to test. So those are points where it's going to be equal to 0. So now I'm going to test points in between. So let's take a look. So if I'm going to plug in, let's say pi over 4. So because I know pi over 4 is right here, right? So pi over 4, that's going to give me a positive, isn't it? Jess? That's a positive. Okay, so now next one. Let's plug in pi. Pi? Yes? Plug in pi, that gives me -1, so that's a negative. And other side of 3 pi over 2 would be 7 pi over 4. Something like that. 7 pi over 4, cosine in quadrant 4 is going to be negative, right? Or positive? It's positive. So quadrant 4, cosine is going to be positive, times 2, so that's going to be a positive right here. So, using concavity test, if it's positive, that's going to be concave. Concave up. If it's negative, it is concave down, right? So we have points of inflection. So it is changing concavity here, right? Yes? Okay, so I have those inflection points. So, and second derivative test, any local extreme. So now, what am I doing here? Oh, yeah, back up the top, sorry. Checking for concavity. I knew I said it. I just like, oh, crap. All right. So it's going to be concave up. So concave up. From where to where? Okay, let's look right here. Okay, so it's going to be concave up from where? So it's going to be concave up from 0 to pi halves. And again, crap. Didn't give myself enough room. That sucks. He didn't want to do that. All right, so it's going to be 3 pi halves and 2 half. All right, so concave down would be pi halves to 3 pi halves. Yes, and my inflection points are pi halves and 3 pi halves. Okay, so now, since I want to know what the actual point is, I know what the x value is, right? So I want to know what the point is. So my inflection point, I'm going to plug in this. So it's going to be pi halves. This is my point of inflection, right? So where does that get plugged into to figure out my y value? The original function. So let's take a look. So it's going to be pi halves, right? Minus 2 times cosine. What's cosine at pi halves? Rad 2 over 2. So rad 2 over 2 times 2? Rad 2. So I'm going to have, it's going to be pi halves minus rad 2. Does that make sense? Or no? Did I screw you guys up there? I need some communication, you guys, besides you guys just checking your Instagram feeds right now. Yes, I'm looking at you. Okay. Questions. I need some questions.
Yeah.
Speak.
Wait, cosine at pi halves is 0, right?
Cosine at pi halves is 0. I don't know. Someone told me it was going to be rad 2 over 2. Yes? Thank you. Oh my goodness. Speak.
Just pi half.
Thank you. So, when we plug in pi halves to cosine, it's not rad 2 over 2, is it? It is 0. 2 times 0 is 0. So, it's going to be pi halves, comma, pi halves. Now, my other one is going to be 3 pi halves. So I'm plugging that into the original function. 3 pi halves.
3 pi halves.
It's going to be 3 pi halves again because cosine at that is going to be 0, isn't it? So it's going to be 3 pi halves. Thank you. Have one person paying attention. Another person over there daydreaming. 2 people over here checking their Instagrams. Everyone else halfway asleep. Are we okay or no? It's Thursday, my dudes.
Oh, it's Thursday.
Are we okay? Is
I'm
it
trying to get through the days, man.
okay? I'm trying to help you get through the day. Okay, so I'm gonna try and help you get through the day. This is it. This is basic of it. So just the concavity, do the hand thing. Remember, you guys are like, look up, do the little hand thing again, right? Okay. You guys, I'm gonna give you guys the rest of the class. I want you guys to work on your work. Okay, advisory is free. You guys can come in for that. Got to get a whole bunch of homework in from you guys. Next week is progress reports again. So, and next week, did I promise you guys a test next week?
Yeah, on Friday next week.
Yeah, I lied.
Which day? Tuesday, Wednesday?
No, I lied. It's not next